sure, but these are the states that matter, I think. Isn't that what we're studying?
Mr. Brown? Oh! What are you doing?
Somebody told me we were studying states that matter today. So I'm looking at the different states that matter.
Oh, so you want to learn about states of matter, do you?
States of matter?
Just wait right here.
Oh.
Okay, Mr. Brown's got a little bit of geo mixed up with a little bit of science, and yes, those two things go together sometimes, but in this case, we want to learn the states of matter. Solids, liquids, gases, and a few other things. So, I think we can learn a little bit about states of matter as well while we're teaching Mr. Brown at the same time and discovering things for ourselves. All right, are you with me? Come on, let's go back and talk to Mr. Brown. All right, Mr. Brown.
Yeah.
I think you're getting some geo stuff mixed up with some science stuff, although they work together sometimes.
Oh,
You want to learn about states of matter as solids and liquids and gases.
Yes!
All right, and we're going to learn a few other things along the way too.
Okay.
Are you ready?
Yeah!
Let's go! All right, Mr. Brown, when we start with the states of matter, the first one that we usually discuss becomes solids. Solids are all over the place, right?
Yeah,
like
yeah.
your goggles, Mr. Brown.
Oh, yeah, they're solid.
This meter stick, solid.
Yeah.
It's got definite shape and definite volume.
Yeah.
For volume review, remember when we had the marbles and we were doing density and we put marbles inside of a graduated cylinder to see how many more milliliters the graduated cylinder of water went up.
Yeah.
So that's water displacement, that's volume. So it's got the definite shape.
It's a circle.
Yeah. And it's got definite volume.
Yeah.
Now, we could change the shape of those things, but not very easily. Okay, we'd have to break it or squish it or something like that. Definite shape and definite volume for solids. Solids can be huge, okay, like a bus. Solids can be tiny, like a little tiny grain of sugar or a grain of sand or a grain of salt or something like that.
What holds the molecules in a solid together?
Ah, good question, Mr. Brown. Chemical bonds are forces that hold those molecules really tightly together to make them become a solid.
Cool. And what do the molecules look like in a solid if we could see them?
If we could see those molecules in a solid, they're usually packed very tightly together.
Oh, that makes sense.
And do you know anything about the periodic table in the solids, Mr. Brown?
Yeah, I was just thinking about that. When we were looking at the periodic table last week, most of the elements at room temperature are solids.
You're exactly right.
Yes.
And let's hope our 6th graders pick up on that as well as they look at their own periodic tables. Well, I think we've got solids pretty much covered. So let's study some other states of matter. Ready?
Yep.
Let's go! All right. Our next state of matter is going to be liquids. Now, liquids are different than solids in that liquids do not have a definite shape. They take the shape of their container usually.
Oh, that makes sense. So this liquid's taking the shape of the flask, where this liquid's taking the shape of the beaker, and this liquid's taking the shape of this plastic container. If there was a liquid in here that we poured in here, it would take the shape of the graduated cylinder. Oh, and the vinegar's taking the shape of that bottle. Cool, that makes sense.
That does make a lot of sense. Lots of different liquids, and if you look, the liquids will change the shape of their container. For instance, we have in a big beaker cylinder right here, and a graduated cylinder, which is much skinnier and taller, the liquid will not stay in the beaker shape, obviously, when we pour it in here. It takes the shape of the graduated cylinder in there.
I can tell how much is in there, can't I?
Exactly, that's the volume. So it has a definite volume.
Ah.
You can measure how many milliliters or cubic centimeters that liquid takes up.
Cool. Say, what do liquid molecules look like?
Oh, remember when we did the solids were packed really tightly together?
Yeah.
The liquid molecules spread a little farther apart, so they're starting to slip past one another. So some people, when they do their hand signals, do solids, and then liquids start to slip past one another. And that's what makes them be able to take the shape of their container.
Hey, and you know what? I remember from the periodic table as well, that there were only 2 liquids at room temperature on the periodic table.
Exactly right. You're really good at that periodic table, Mr. Brown, and hopefully our 6th graders have paid attention to theirs too and can find which 2 liquids are listed on the periodic table at room temperature. All right, well, we've covered some liquids here. Definite volume that you can measure, as you pointed out, and they take the shape of their container that we kind of reviewed right here. So let's find out about some other things about states of matter, shall we?
Sounds good.
All right, let's go! All right, Mr. Brown, next we're going to cover the state of matter called gases. Here they are.
Wait a second. There's nothing here. We had some solids to look at. We had some liquids to look at. You trying to fool me, Mr. Kamlik? Where's the gases to look at?
The gases are everywhere, thank goodness, on this planet. And that is one of the definitions of gases. We cannot see gases, actually.
Why?
Gases, molecules, are so far spread apart that we, with our human eyes, cannot see them.
So there's gases around me right here and that make up the air.
Exactly. A whole bunch of nitrogen, some oxygen, and some other trace amounts of gases and things like that too. Yeah. So the molecules are spread so far apart that they have no real definite shape and no real definite volume. They're very tough to measure.
And those molecules are kind of flying around like individuals, I bet.
Exactly.
Yeah.
Instead of packed tightly together where we could maybe see them, they are all over the place. So like we said, some examples of gases keep us alive. We breathe in air, and it's the oxygen in the air that helps our lungs go and breathe and get energy to our systems and things like that.
Cool. Hey, and I remember noticing on the periodic table that most of the gases were on the right-hand side, that far column we called the noble gases, and then a few other ones in there, only 10 or 12 of them on the periodic table.
Very right. You're good with that periodic table again, Mr. Brown, and hopefully our 6th graders can look at their periodic table and find some of the gases as well. So, are you ready to find out some more things about what these solids and liquids and gases do?
Absolutely.
Then let's go! Well, now, Mr. Brown, you can see here, even though it's not your birthday or my birthday, we've got a candle going. And we're going to do some things with solids, liquids, and gases, or states of matter, that add heat. So if you would safely hold that test tube, Mr. Brown, and notice how he's holding it from way at the end, all right? And he's got the clamp up there, and he's not squeezing it together with his hands. And we're going to put that orange M&M is inside the test tube.
Solid.
Yeah. And we're going to put that over the flame to heat it up. Now when we heat up a solid, those solid molecules that are packed usually tightly together with those chemical bonds start to move apart a little bit more. And we can see what happens right there. It doesn't melt in your mouth, or it doesn't melt in your hands, it melts in your mouth. The M&M is starting to get goopy.
Ooh, yeah.
Look at that.
So when a solid changes to a liquid, what do we call that?
We call that melting.
Ah, yes.
We just add heat to a solid to cause those molecules to move a little faster and melt. Now, most solids, you'll find on the periodic table, will list a melting point if you research far enough, or depending on how intricate your periodic table happens to be. So even iron, metal, will have a melting point to it, where you can take those really solid molecules and move them apart just simply by adding heat.
Cool.
Actually pretty hot, huh?
Yeah, pretty hot.
Yeah. So now those molecules that have moved farther apart actually start to turn into its liquid phase. And there's something else we can do with the liquid coming up. And we'll show you that when we do something else. But again, we melted something, and all that means is we added heat and changed the solid into a liquid.
Cool.
All right, ready again?
Yep.
Let's go! All right, Mr. Brown, here we have sugar molecules. Okay. And we can see those because they are a solid.
Yep.
And inside of this beaker, we just have plain old water.
Okay.
Dihydrogen monoxide, and that is in its liquid state. So what we're going to do now is we're going to take a scoop of sugar, very nice, and we're going to pour it in there, and stir it up if you would, please. I didn't know you were such a magician, Mr. Brown. Look what you did.
So the solid changed to a liquid.
It did not change to a liquid. That is a total misconception. Now, you can't see the solids in there anymore, can you?
No, the solid sugar molecules disappeared in the liquid molecules.
Did disappear. And instead of them actually becoming a liquid, they're still there. We can still get them out of there.
Oh.
They are playing a little game of hide and seek.
Oh, so the solid molecules must hide somewhere by the liquid molecules.
You're exactly right. And here's something for our 6th grade brains to really have a tough time to understand. It is that in between each one of those liquid molecules, there's total empty space. There are lots of little pockets of empty space in that water. And Mr. Brown, they're so tiny that you can't see them. And if you dipped your finger in there, it would still get wet no matter where you put it. The empty spaces are so incredibly tiny that only some of those little tiny solid molecules can go in there and hide.
And if we could look super close, this is kind of what it would look like.
Oh, very nice over there. Exactly right. You can see by that graphic that those sugar molecules hide in those little pockets of nothingness that are in those liquid molecules.
So this is kind of like when I make some lemonade or Kool-Aid at home.
Exactly right, Mr. Brown. This is what happens when things dissolve. The solids do not change to a liquid. They do not change states of matter. They simply hide in between those liquid molecules.
Good misconception to clear up there, Mr. Kamlick.
Exactly.
Yeah.
So, dissolve really means the solid molecules hide inside of those liquid molecules where there's empty pockets for them to hide.
Cool!
Exactly. Well, that's the dissolve part of states of matter right now. Let's move on to something else. Ready?
Yep,
Let's go! All right, Mr. Brown, we've got a beaker of liquid right here. And what we're going to do with that liquid is we're going to add cold temperatures to it. Just like Wisconsin has cold temperatures in the wintertime. And to do that, we're going to put it in the freezer right here. So go ahead and do that. Now, then we'll wait a certain period of time, and we'll see what happened to that liquid. All right, Mr. Brown, now we've had that beaker of liquid in there for quite some time now. So it's been in the freezer, we've added cold temperatures to it. Let's see what it looks like now.
Whoa! Look at that! Turned into some solids!
It did! So the water turned into ice, the liquid turned into a solid. What happened was, those liquid molecules came closer and closer together because they were cold. They're still moving, but they're not moving as fast. Now they have a couple of things to them that make them a solid.
So when we take a liquid and we add cold temperatures and turn it into a solid, what's that called?
That is called freezing.
Ooh.
So now, instead of a liquid that takes the shape of its container, these things have a definite shape and a definite volume.
Cool, we just saw something freeze!
Yes, we did. All right, Mr. Brown, ready for the next part?
Yeah!
All right,
Let's go!
All right, so here again we're working with heat, only instead of a candle this time, we have a hot plate, almost like a single burner of a stove.
Yep.
And inside of there, we've got some boiling water.
Oh, a liquid.
Yeah, and the definition of boiling actually leads us to our next science term, and that is evaporation.
Ah, so when that liquid is turning into a gas.
Exactly right. And inside of the word evaporation, there's that word vapor. Now, if you hold that, good, Mr. Brown, since you've got a white lab coat on like I do, you can see that the liquid is coming up right here. Now, this stuff that we usually call steam is still water vapor. Okay, that's water, condensed water vapor. So it's still liquid form. The instant that you can't see it anymore and it disappears, that is when it turns
right up
into
here, it's turning into a gas.
You're exactly right. It's turning into a gas up there.
So when a liquid turns into a gas because of heat, that's called evaporation.
Exactly. And it doesn't just disappear. It's still out there. It's just those molecules are now so spread apart. Those single molecules going all over the place, zooming around, we can't see them anymore.
Oh, okay. So what happens when a gas turns back into a liquid? Or how does that happen?
Well, let's see. If we added heat to change the liquid into a gas, what do you think we'd have to add to the gas to turn it back into a liquid? Cold! Let's try that out, Mr. Brown. So, what Mr. Brown's going to do right now, he's got a dish right here, and inside that dish, he has some ice cubes. Reason for that? He's not trying to melt the ice. It's just making the dish cold, the bottom of the dish cold. Now, when that warm gas comes up and evaporates against that cold dish is going to turn those really spread apart molecules back together again. They're going to condense, condensation, and eventually, oh, I see it right now. On the bottom of that dish, there are little tiny droplets of water. Take your finger there, Mr.
Oh, yeah.
Look at that. Now, some kids will think that the liquid from those ice cubes somehow found their way through the dish and leaked out. That doesn't happen. Not that quickly anyway. You could get it to happen, but absolutely not that quickly. Where that liquid came from was actually inside this pot of boiling water. Those gas molecules came up, they cooled down, and those molecules came together again and formed a liquid. They condensed into condensation.
So when a gas turns back into a liquid because of cold temperatures, we have condensation.
Cool it down, condensation.
Very cool.
There we go. It's exactly cool. So, lots of stuff going on in here. This actually fits in a lot with our weather unit that we'll study later this year too, Mr. Brown. All right?
Cool.
All right. Well, we've got some other stuff about states of matter to show you. So, how about we go do that?
All right.
Let's go! So this is the well. It's about all the time we have.
Yeah.
Right? Okay. Well, Mr. Brown, I hope you learned a lot about states of matter.
Yeah, it's not so much the states that matter, but the states of matter. Say, we learned a lot of new terms and pictures and stuff like that. Do you think we should help the 6th graders remember that too?
I think so as well.
Okay.
So you ready?
Yeah.
Let's review!
Solids have a definite shape and volume. Forces called bonds glue their particles or molecules together.
Liquids do not have a definite shape, but they have a definite volume. They take the shape of the container that they are in. The molecules start to slip past one another.
Gases do not have a definite shape or definite volume. The molecules fly around in space as individuals. They're moving so fast, we cannot see them with our human eyes.
If you melt something, you are simply taking a solid and changing it to a liquid. Heat causes melting.
A big misconception in states of matter is dissolving. When solid molecules hide in pockets of liquid molecules, like in the sugar water or Kool-Aid that we made, dissolving takes place.
Here in Wisconsin, we know a lot about cold temperatures. When we add cold temperatures to liquids, we can freeze those states of matter. So, when liquids change to solids by adding cold temperatures, we call that freezing.
When we have a liquid and it's changed to a gas by adding heat, like we did with the boiling water, we call that evaporation.
When that evaporated gas changes back to a liquid by adding cold temperatures, we call that condensation. We condense those molecules back together from a gas into a liquid.